what was the need of operations on N Ary relations? So when we get the Cartesian product, we get it in the form of huge data. And now this data needs to be studied. So to study the data, we need to sort, add or delete some of the information. To do so, we have in operations. The operations are join operation, selection operation and projection operation.
What is operation? Let's take an example of an equation 3 plus 2, which we know is equal to 5. Here, the plus sign is the operation which performs a mathematical action of addition of 3 to 2. In other words, operations are what performs the mathematical operation to operands. Here, the operands are N Ary relations. The most basic operations for N Ary relationships is selection operation. So let's learn more about that.
So today we'll be learning about the selection operation. So now let's see the definition of it. Let R be an N Ary relation and C be a condition that elements in R must satisfy. The selection C maps the N Ary relation R to an N Ary relation of all n tuples that satisfy the condition C. We have an N Ary relation R and we apply a condition C to it, and all the n tuples on which the condition C is satisfiable will create another N Ary relation, and that is called selection operator.
So the another example of this selection operation is we have this BBA student's name and age. We can notice this is a 22 record original N array, and after applying a condition C, that is condition of age greater than 18, we can see how significantly the smaller N array relation gets.
I have the non-veg main course from Garba restaurant, but I only have 300 rupees. The whole list of non-veg main course is the original N Ary relation. The condition will be less than 300 rupees. When I apply this condition, I will get a new N Ary relation which satisfies the condition.
Projection field I1, I2 till IM, where I1 less than I2, so on till IM, maps the n tuple A1, A2 till AN to the m tuple AI1, AI2 till AIN, where n is less than equal to n. So in other words, we keep the I1, I2 and so on till IN element and delete the rest. So if we take T12, we'll just keep the first and the second element and delete the rest element of the tuple.
So in this operation, we remove the same fields in every record of the relation. So in an example of a relation a comma 1, b comma 2, c comma 3 until z comma 26, when we remove the numbers, the resulting relation will be a comma b comma c until z. So this operation, in other words, this operation removes columns from the tabular representation, and unlike the previous one containing n tuples, the new N Ary relation form contains m tuples where m is less than n.
So we will be looking at some examples of projections on relations. The first example, example 8, shows a projection P1, 3 applied to the tuples containing 4 elements 2, comma 3, comma 0, comma 4, Jane Doe, comma 2, 3, 4, 111, 001, comma geography, comma 3.14, and A1, comma A2, comma A3, comma A4. So when this projection is applied to these tuples, it changes these tuples to 2, comma 0, Jane Doe, comma geography, and A1, comma A3 respectively, where the first and third elements are displayed, but the second and the fourth elements are deleted from each tuple. The next example is example 9, where a projection P1, 4 is applied to table 1. Table 1 has the column student name, ID, number, major, and GPA. And when this projection P1, 4 is applied to table 1, the second and third columns are deleted and only the first and the fourth columns are projected. Table 2 shows the result of the projection P1, 4 on table 1, where only the student name and GPA columns are displayed. So some projections applied to the table for a relation may result in fewer rows. This happens because some of the tuples in the relation have identical values in each of the components or other components of the projection, and they only disagree in the components which were deleted by the projection. So this can be understood using the example 10, where a projection P1, 2 is applied to the relation in table 3. Table 3 has the column student, major, and course. So when the projection P1, 2 is applied to table 3, the third column is removed and only the first and the second columns are projected. This can be seen in table 4, which shows the result of the projection P1, 2 on table 3. Table 4 is also observed to have fewer rows when compared to table 3. This is because there are identical values in the first and second columns, and only the third column has disagreeing values in the table. So when the third column is completely removed, the identical values in the first and second columns are removed, and only the distinct values are displayed or projected in the result.
Projection operation is very useful. Sometimes some information is useless and not important in our analysis. So we remove those data and make the data more compact and easier to understand. So let's see for an example. This was our assignment in which we tried to analyze the factors leading to physical and mental health issues. So we collected the Google form responses. So we got many columns, like quite a lot of columns. So then we for the analysis, timestamp, the name part were useless. So we deleted these columns, which lessened the number of columns and made our task easier.
So let us discuss about degree. Okay, degree is nothing but number of elements in a tuple is known as its degree. For example, if we consider a set containing two tuples like 2, 3, 4 is one tuple and 4, 5, 6 is another tuple. So how many elements are in this two tuple? I mean in each. There are 3 elements, right? So the degree of this tuple is 3.
Now let's see what is the join operation. Let R be a relation of degree m and S a relation of degree n. The join GPRS where P less than equal to m and P less than equal to n is a relation of degree m plus n minus p that consists of all m plus n minus p tuples a1, a2 till am minus p, c1, c2 till cp, b1, b2 till bn minus p, where the m tuple a1, a2 till am minus p, C1, C2 till Cp belongs to R and the n tuple C1, C2 till Cp, B1, B2 till Bn minus B belongs to S. So in other words, we combine two tables out of which some of the columns are same. So now we get a new table which has the columns, the distinct columns and the same columns which are counted just once. This table results into a new tuple forming and a new N Ary relation which is formed.
Okay, in this lecture, let's talk about joint operation. As we all know, what is the meaning of joining? Joining is nothing but it's just a combining two things together, no? So it's joining. So the same here goes for the joining operation. Let's consider tuples, right? Two different tuples consisting of related information. If we combine the two tuples into the same thing, it is called joint operation. So it is used in DBMS. DBMS is nothing but database management systems. So why should we use DBMS? It is used to store, collecting or manipulating, accessing data. Actually, it is very secure to use DBMS. It consists of large number of data which we can't even imagine. So it is called DBMS. So now let's take an example. If we have a tuple consisting of, see, this is a tuple consisting of employee name and employee's number, and the another tuple. This consists of employee's name and their salaries respectively. So if we combine this two together, this combined tuple consists of employee's name, their number and their salary. So this is called joint operation.
Okay, so the join operation is used to combine two tables into one table when one of these tables shares some identical fields. For example, I have a table here. The first table says teaching assignments. The table has three columns, namely professor, department, and course number. The table is given as there are three professors. There are four professors' names mentioned. One's Cruz, Farber, Grammar, and Rosen. And the department mentioned are zoology, psychology, physics, computer science, and maths. Here, on the other hand, I have another table, and it is of class schedule, right? So the department here I mentioned computer science, maths, physics, psychology, and zoology. And rest of the three columns mentioned here are course number, room, and time. So here we see that the identical fields that we have between both of the tables are department and course number. So if I have to apply join operation between both of these tables to combine it, the resultant table would look something like this, that I have the column for professor, I have the column for department, I have the column for course number, I have the column for room, and I have the column for time. So the resultant table would look something like this. So this is basically what the join operation does. What the join operation does is it helps you combining two tables. It helps you combining given two tables when they share some identical fields. Thank you.
So sometimes the data we have is not sufficient for the analysis which we want to do. Like for example, let's see if we have this data which shows the countries and the area of that country, and the other data which shows the countries and the population of that country. Now if I want to find population density, each data won't be sufficient individually, but then if I combine the data I can easily find the population density. So in such cases, join operation is very helpful. Here the data has very few examples, but like in practical analysis, the data is very extensive and join operation comes out to be a great tool.